The next thing that I'm going to discuss is generating random numbers in C. Okay, generating random number is very useful in different solving different interesting problems. So let's learn how to generate random numbers in C. Okay. So suppose I want to generate 10 random integers. Okay. So let's see how can I generate this. So I want to generate 10 random integers. Int r equal to, there is function called rand function. Okay. That resides in standard library.h. Or if you want to use this, you need to include standard library.h. So this rand functions returns a random integer in between 0 to the maximum limit of an integer. Okay, in between 0 to the maximum limit of an integer. So let's you can see that a set of 10 random integers has been generated. Okay. So this rand function is generating different random numbers in each and every iteration, random integers in each and every iterations. Okay. All right. Now let's try to understand that if I run it several times, will this set of random numbers differ or not? Okay. So let's rerun once more. If we notice that the set of numbers that are getting generated in the second run is exactly identical to the set of numbers that I have generated in the first run. Okay. If I run once more, then also I can see that the same set of random numbers are getting generated. Okay. So what's happening? Because while generating random numbers, I generally want to ensure that every time I'm running the program, it is generating different set of random numbers, right? But now I can see that, or here I can see that it is generating the exact same set of random numbers. All right. Okay. So let's try to understand what's happening. So let's see what are the things that may happen inside the rand function. Rand function is a function that has been developed and inbuilt inside the compiler. Okay. So let's see what are the conceptual details inside this rand function. So the way this works is the following. Suppose there is an initial integer, okay, so which is initialized to 1. So the first random number that are getting generated is some function of this initial integer that has been set to 1. Okay, the first random number that is getting generated is some function of this. Okay, so for example, a into s0 square plus b into s0 plus c mod d. Okay, something like that. So it's a function of s0. Okay, this is a function of s0. Clear? Again, I'm not saying that this is the function that has been used exactly inside the rand function, but I'm just giving an idea that S1 can be a function of the initial value, initial variable that has been set by default to some value. Okay. Then maybe the second number that is getting generated is A into S1 square plus B into S1 plus C mod D. Okay. Here A, B, C and D are some constants that has been predefined. Okay. Similarly, S3 equal to A into S2 square plus B into S2 plus C mod D. And in this way, 10 different random numbers got generated. But all these numbers started from S0. Okay, all these numbers started with a function of S0. So that's why even if I am running multiple times, S0 is set to a default value 1, and that's how S1, S2, S3 and all the 10 numbers that are coming are exactly identical. Maybe even if I am running 10 times or 100 times, as S0 is set to the default value, all the other numbers are coming identical. Clear? So these S0 value are called seed value. Okay, S0 value are called seed value. Okay, which is initialized to 1 by default. Okay, by default, the seed value is initialized to 1. That's why multiple runs are generating the same set of random numbers. Clear? Okay, so let's go back to the program and see how we can change this seed value and what is going to be the effect of this changed seed value. So there is a function called strand that we can use for changing the seed value. Okay, so as I said, by default strand is set to 1. Okay, so if I run this program with strand 1, you can see that you are getting the same set of numbers. Okay, basically strand that shows that strand is by default set to 1. Okay, if I change from 1 to 2, then we can see that the value that are getting generated is different than the previous set of values. Okay, if I change it to 3, for example, then another set of 10, another set of 10 values are getting generated. Okay. So if I change a strand, the program is generating different set of random numbers. Clear? So the question is, what do I want? I want to generate different set of random numbers in different run. That means I want to ensure that this set of random numbers changes with time. Okay, at different time instance, if I run the program, it should generate different set of random. So this seed needs to be dependent on time. Okay, so how can I make this change? Instead of putting 1, 2, 3 different constant number, I can write time null. So this time function resides in time.h header file, and this changes in each and every second. Okay, this time function changes in each and every second, because this time function returns the number of seconds that has been elapsed from a reference point which was set to, I think, 1st January 1971. Okay, if I am not wrong, this time function basically returns the number of seconds that has been elapsed from 1st January 1971. Okay, or some time frame. So this seed, if I write time null, every second it is going to change. Okay, so if I run this in different in interval of different seconds, it is going to generate different set of random. Okay, so let's see. So in this, at this instance, it is generating this set of random numbers. Okay, let's run it once more. Now you can see that it is generating another set of random. Okay, if I run once, it is going to, if I run once more, it is going to generate another set of random. Okay, another set of random numbers that is generated. So each and every different time instance, it is going to generate different set of random numbers. Okay, clear to everyone? So once you, or if you want to, write a simulation where you need to generate random numbers in different random numbers in different time, then you need to use the srand function. Clear? Okay. Now let's see. So we have seen that this rand function is generating different random numbers in between 0 to the maximum limit of an integer. Okay. So this maximum number that is getting generated is stored in a constant or micro called rand max. Okay. So if you print rand max, let's see what is going to be the maximum value of a random number. Okay. This is a constant that is already set to the maximum possible value that a random function can read. So here it is showing that the maximum random number generated is 2147483647. Okay. So if you recall correctly, this is the maximum limit of an integer. All right, a maximum limit of an integer is 2 to the power 31 minus 1. If you recall, 2 to the power 31 minus 1, which is nothing but 2147483647. Okay, which is same as this. So rand max is basically, or the rand function is going to generate random numbers in random integers in between 0 to rand max, which is nothing but the maximum limit that an integer can store. Clear? Okay. All right. So with this understanding, let's take some simple example and let's solve some problems. Okay. Okay. So here I have used rand function to generate any random integers. Okay. Now let's take a specific problem. So suppose you are rolling a die. Okay. Suppose you are rolling a die, and suppose you are rolling it 10 times, and you want to see the outcomes. Okay. So if you roll a die, the outcome will be in between 1 to 6. Right. So how can you emulate that, or how can you simulate this? I'm going to roll this die 10 times. And then in every iteration, it is generating a random integers in between 1 to 6. Okay. Rand function is giving a random number. A rand function is generating any random integers in between 0 to rand max. But here, in this experiment, I need to generate random integers in between 1 to 6. Okay. So how can I do this? Rand function will generate random numbers, any random integers. If I take a mod of 6, then what shall I get? This will generate a random integer in between 0 to 5. Right? Okay. Rand function is generating any random integers. If I take mod of 6, it is going to generate random integers in between 0 to 5. So I want to generate random integer in between 1 to 6. So I need to add 1 with this. Okay. So this whole thing is going to generate a random integers in between 1 to 6. Clear? And then if I print, so let's print 1 integers in every line. So now you can see that it is generating random integers in between 1 to 6. Okay, and again every time if I run this program in different times, because of this srand function, it is generating different set of random integers in between 1 to 6. Clear? Okay, now let's see. So if we roll a die, what is the probability that the outcome is going to be 6? From your probability understanding, what is going to be the probability that the outcome is going to be 6?
1 out of 6.
1 over 6. Okay. So let's see that through simulations whether I can get that number or not. Okay. Or how can I simulate that experiment? Okay. So how can you simulate that experiment? Well, if I continue this experiment several thousand times, and if I keep track of how many times I'm getting 6, then the probability of finding 6 is the number of times I'm going to get 6 divided by the number of experiments that I have conducted. Right? That is basically the concept of probability. Okay? So let's do the same experiment. Suppose I am running it 100,000 times. Okay? And then every time I'm rolling this die, I'm basically checking. Let's remove this print statement. So every time I'm rolling this die, I'm basically checking whether the outcome is equal to 6 or not. If it is 6, then I'm implementing a counter which should be initialized to 0. So every time I'm getting 6, I'm implementing counter, and then at the end of the experiment, I'm basically calculating the probability of finding 6. So probability is a fraction. So it is equal to counter divided by 100,000. 0. Alright. So let's see. So the outcome is 0.167240. Okay. So if I calculate 1 by 6, it is going to be 0.166666, which is very close to 0.167. Okay. So basically, by simulation, I am checking whether my outcome is matching with the theory, with my theoretical understanding or not. And we have seen that it is indeed matching. Okay. All right. So now let's go to the next problem. So suppose I am rolling 2 dice. So what is the probability that both of the faces are going to be 6? What is the probability?
1.6 times 1.6.
Yeah, so that means 1 by 36. Right? If I am rolling 2 dice, the probability of getting 2 6 is 1 by 36. So how can we simulate this? It's very simple. I will repeat the experiment several thousand times. Every iteration, I am going to roll 2 dice instead of 1. D1, dice 1 and dice 2. And then I am going to check if dice 1 is equal to 6 and dice 2 is equal to 6. Then I am going to implement the counter. So let's see what number it is showing. It is showing us 0.0267. So let's see what is the value of 1 by 36. So it is indeed 0.0277, which is very close to 0.0267. Okay, so this is also matching with our expectation. All right. So this kind of simulation is also called Monte Carlo simulation. Okay, Monte Carlo simulation means you basically simulate an event multiple times, and at the end of the number of iterations, you are basically averaging and finding out the probability or uncertainty of certain events. This kind of simulation is also called Monte Carlo simulation. Clear? Okay. Now let's see. So till this point, I have generated random integers. Okay. But what's about fractional random numbers? So there may be situations where we need fractional random numbers. How can we generate fractional random numbers? So suppose I want to generate a random fractional random numbers in between 0 to 1. Okay. Suppose I want to generate random number in between 0 to 1. How can I do so? Well, it's not that difficult because we know that rand function generates a random integer in between 0 to rand max. So if I divide rand by rand max, I'm going to generate a fractional random numbers in between 0 to 1, right? So let's see whether we can write a program that is going to generate 10 fractional random numbers in between 0 to 1. I is equal to 0 less than 10, I plus plus. Let's declare a float variable r1 equal to rand divided by rand max. Okay. Here I need to do a type conversion. Then I am printing. Okay, so let's see. So now you can see that it is generating a set of 10 random numbers in between 0 to 1. Clear? And again, if I run it multiple times, because of the srand function, it will generate different 10 random numbers in between 0 to 1. Clear? Okay. Now suppose I'm saying that, okay, instead of generating 10 random numbers in between 0 to 1, generate 10 random numbers in between 0 to 100. How can I do so? It's pretty simple. If you can generate random numbers in between 0 to 1, then generating random numbers in between 0 to 100 is nothing but 100 multiplied by rand by rand max. That's it. So this is going to generate 10 random numbers in between 0 to 100. Clear? And different times we will get different random numbers in between 0 to 100. Clear? Okay. Now if I say that, okay, instead of generating random numbers in between 0 to 100, generate random numbers in between 500 to 600. How can you do so? It is nothing but 500 plus 100 into rand by rand max. This is going to generate random numbers in between 500 to 600, right? So here we can see that it is generating random numbers in between 500 and 600, right? So in this way, you can generate both random integers as well as fractional random numbers in between different intervals or in different intervals. All right, based on your use cases, you can generate random number in different intervals. Clear? Okay, everyone is clear with this concept? Okay, so let's use this random number generation idea to solve a very interesting problem, which is about encryption and decryption. Okay. So let me elaborate that problem in the notepad, and then I'm going to come to the terminal and implement it. Okay. So encryption and decryption. Let's see. So first, let's try to understand what is encryption and what is decryption. Okay. So suppose you want to send a message M to your friend. Okay. So what do? You send it, and you want to send it through a channel that is not secured. Okay. All right. So the point is, the message that you are sending is going through some insecure channel where multiple observers are reading your message. All right. Suppose you are sending it through the internet. In the internet, there are multiple eavesdroppers that are trying to intercept your message. Okay. So if you just send the raw message, then the interceptors are going to easily intercept and find whatever you are trying to send to your friend. Right. So how to exchange the message in a secret fashion? Okay, that's how the encryption and decryption is done. So in encryption decryption, in your end or at your end, you are encrypting the message, okay, with a key that you shared secretly to your friend, and your friend is decrypting the message whenever he is getting it. Okay, so let's see. So at your end, you are encrypting the message with a key that is shared in between you and your friend. Okay, so here I am using the XOR function. I'm coming to the details in a minute. So at your end, instead of sending M directly, you are sending M XOR key, okay, to generate a cipher message. Okay, you are not sending the original message M, you are XORing with key and then producing a cipher message. And this cipher message is basically look like a jargon that has no meaning. Okay, and this cipher message you are sending it through your insecure channel. So whenever your friend will get the cipher message, your friend and you share the same key. So it is going to do the reverse operation. It is going to do XOR with the key to produce the actual message. Okay. And here I am going to show you that XOR has the property that if you XOR with the key in the source end, and if you XOR with the ciphertext with the key in the destination end, you will get the same message. Or let me put it in a different way. If you take your message and XOR it with the key, then it will produce the ciphertext. And if you take the ciphertext and XOR with the key, it will produce the original message. Okay. XOR has this very interesting property. Okay, let's see with an example. So what is the truth table of XOR operator? Suppose A and B are two propositions. So when both A and B are false, the XOR outcome is going to be false as well. If any of them are true, the outcome is true. And if both of them are true, then also the outcome is going to be false. Okay, this is the truth table of XOR operator. Okay, so let's use this and let's take an example to check whether this property is holds or not. This property is holding or not. Okay, so let's take a message or any random set of bits, say 110101, any random set of bits, and let's take a key which is of same length of the message. So again, let's take a random set of keys 011011. Okay, so in the source end, you are doing an XOR in between M and K. So M XOR K is going to be equal to 11 is going to be 0, 10 is 1, 1, 1, 1 is again 0, 1. Okay, so this is your ciphertext that you are sending it to the channel. Okay, so this ciphertext is very different than the message text. So anyone who will see the ciphertext will have no idea what is there in the message text. Clear? Okay. Now what's happening in the receiver end or your friend's end? Your friend is taking this ciphertext and then XORing with the key which has been shared by you. Okay. So he is going to XOR with the key which is 0 1 1 0 1 1. So if you do C XOR K, you will get 1 1 1 is 0 1 1 1 is 0 1 1. Okay. And if you notice, this is exactly same as your message text. Okay. So whatever you are transmitting, or whatever you want to transmit, you are getting it at your friend's end. Okay. So this is a very peculiar property of XOR function. All right. If you XOR with the same key, you can regenerate the original message. All right. So that's the basic understanding of encryption decryption. Okay. Now in real life, encryption decryptions are even more complicated. Okay, these are not, at least in these days, these are not that simple, but at least this is good enough to give you some understanding of how encryption decryption works. Okay, clear to everyone? Okay, so let's write a program that will take any message text. Okay, I'm going to generate or I'm going to give a string that I want to transmit, and then let's generate a random key that has of equal length of the message text. Okay, so just let's generate a random key and then let's do this operation. So the random key is shared in between you and your friend. Okay, so I'm going to generate a ciphertext, will transmit it to your friend, and your friend will take the ciphertext and then XOR with this random key that has been generated and shared, and we'll see whether it is able to generate the original message or not through program. Okay. All right. So let's go to the terminal and let's implement. So let's declare a string called message. Okay. And here let's put some text. Say today Monday, CIS 2107, we are learning C. That's it. Okay. All right. So this message I want to transmit, but in a secret fashion. All right. So what did I say? First, I need to generate a random key, and the random key should be of equal length of this message. Okay. So first, I need to find out the length of this message. I know how to find out the length of this string using the string length function. And I need to include string.h. Okay. All right. So now I need to generate len number of random characters. Okay. And let's declare a string called key, which is going to store all these random keys. So the key will be of length len plus 1. Why? Because len number of characters I need to generate, and as it is a string, it needs to be terminated with a termination character. Okay, len number of characters I need to generate, and the string needs to be terminated with a termination character. Clear? Okay. Now let's see how can I generate random characters. Okay. So to generate random characters, we need to generate those ASCII values. Okay. So we need to first check what is the range of ASCII values that will produce valid characters. So let's go to the ASCII table and see what are the range of ASCII values. So you can see that the ASCII values varies from 0 to here 127, and some extended ASCII codes also produce some characters like this that will varies from 128 to 255. Okay, so basically in total the ASCII characters or the ASCII value varies from 0 to 255. Okay, so if I need to generate random numbers in between 0 to 255, okay, to produce random characters. So let's, how can I generate random integers in between 0 to 255? We have already learned. Right? Okay, so let's, so for I is equal to 0, I less than len, I plus plus, I'm going to write key of I equal to rand mod 256. Okay, because I need to generate random integers in between 0 to 255. Okay, I need to generate ASCII values in between 0 to 255. So that's how I'm taking mod of 256. Clear? And then at the end, this string needs to be terminated with a termination character. Clear? Let's see whether it has generated random key or not. Yes. So let's see, let's run this program and see. So I'm using rand, so I need to use standard library.h. So you can see that the key that is generated is like this. Okay. However, if I run it multiple times, it is going to generate the same key. So I need to use the srand function. And include time.h. So now if I run it different times, it is going to generate different set of random keys. Okay. So I have generated random keys successfully. Yeah. Okay. Now next I need to encrypt. So for storing the encrypted text, I am declaring another string called encrypted text that can store a maximum of 100 characters, and then I need to do character by character XOR in between message and key. Okay, all right, so let's do that. For I equal to 0, I less than len, I plus plus, encrypted text of I equal to message of I XOR key of. This is the XOR operator, which also works on characters. Okay, whatever I have shown in bits will also work on characters. So it is going to do character by character XOR. Okay. And at the end, I'm going to terminate the encrypted text with termination character. Okay, so let's see how the encrypted text will look like. So you can see that the encrypted text looks like this. Okay, so from this text, no one will be able to interpret that whatever message you want to transmit. Okay, there is no link. So you can see that different times it is producing different encrypted text because the random keys generated is different. And from this message, it is very difficult to understand what is the original message. Okay, so if you transmit this message to an insecure channel, the interpreters or the eavesdroppers will not be able to understand what the original message is. Okay, or at least it is very difficult to understand. Okay, now so ultimately this message will reach to your friend's end. So what your friend will do, he is going to do decryption. So for decrypting, he is going to declare a string called decrypted text, and then he is going to do the reverse operation. For I is equal to 0, I less than len I plus plus. He is going to take the encrypted text that you have sent, XORed with the key that you have shared with him. The decrypted text needs to be terminated with a termination character. Okay, so let's see what the decrypted text looks like.
You need to change the len.
Yeah. So you can see that the decrypted text is exactly matching with the message text that we have sent. Okay, and every time I'm running it, it is going to generate different random key, different encrypted text, but the same regenerated decrypted text. Clear? So by using this principle, you can easily send the message that you want to send to a friend in a secret fashion. Alright. Now let's take another interesting example, okay? For where we are going to use the random number generator and generation principle. Alright. Okay. Let's see. So let's go to my notepad and let's see one example and let's solve it. So let me describe one technique for finding the value of pi using a real experiment. Okay. So you know that the value of pi is approximately 3.14. Now let's see how we can find this value using a real experiment. Okay. So let's assume that you have a square of side D and inside the square there is a circle. So this circle will have a diameter of d as it is inside this square. Okay. Now suppose you are throwing some arrows randomly in this space. All right. And so some arrows will be inside. If you throw the arrows randomly in the space, some arrows will be inside the circle, otherwise they are going to be outside the circle. Okay. So if the arrows are inside the circle, we'll say that it's a hit. Okay. And if they're outside the circle, we'll say that these are miss. Okay. Okay. So then how can I find out the probability of a hit? So suppose you are throwing some arrows randomly in this space. So what is going to be the probability of hit? Okay. So the probability of hit is going to be nothing but the area of the circle divided by the area of the square, right? So probability of hit is nothing but the area of the circle by the area of the square. Okay, clear to everyone? So what is the area of the circle with diameter d? Area of the circle with diameter d is pi d square by 4. All right. And what is the area of the square? Area of the square is d square. Clear? So d square will cancel out. Ultimately, we will get pi by 4. Okay. So therefore, I can write that the value of pi is equal to 4 into probability of hit. Okay. And that's a very interesting outcome, right? Because you can do a repeated experiment by throwing some arrows in this space, and if we find out the probability and then multiply it by 4, you will get the value of pi. That means that by using real experiment, you will be able to find out the value of pi. Okay, that's a very, very interesting result. Clear? Okay. So let's try to simulate this process by doing such similar experiment, and then let's try to find out the value of pi from the simulation. Okay. And for the sake of simulation, let's make the problem a little bit simple. So let's assume that the center of the circle is 0, 0. And the coordinate of this corner is -1, -1. So -1, -1. The coordinate of this corner is +1, -1. Coordinate of this corner is 1, 1. And this is -1, 1. Okay. All right. So this formula will work for any center coordinates or any other coordinate system. Okay. But just for the simplicity, I'm just assuming this. Okay. So now I need to generate random coordinates x and y, which will be in the range of -1 to 1, right? Both x and y is going to be -1 to 1. Is this clear? Okay. So if I generate random coordinates x and y in this space, then x will be in the range of -1 to 1. Y will be in the range of -1 to 1. Clear? So I know how to generate random numbers in between -1 to 1. Okay, or at least I will be able to simulate this. Now once I will generate these random coordinates x and y, I need to check whether x and y are inside this circle or not. So suppose you have an x and y over here. How can you understand from the coordinate whether x and y is inside this circle? You will find out the distance, and if the distance is less than the radius, then it is inside the circle, right? So what is the distance formula? Distance is square root of x minus 0 square, which is x square, plus y minus 0 square, which is y square, right? This is equal to the, this is, if it is less than equal to the radius, here radius is nothing but 1, right? Then it is inside the circle. So that means if x square plus y square is less than equal to 1, then I will say that there is a hit. Okay, so that means if I generate random coordinates x and y, and then if I check whether that random coordinates is inside this circle or not, then I'll be able to find out that it's a hit. And if I repeat this process several times and I will count how many times I am getting a hit or how many fraction of time I am getting a hit, then I'll be able to find out the probability of a hit. Okay, and then I need to just multiply it by 4 to find out the value of pi. Clear? Okay, so let me quickly simulate this and check whether using this experiment we can find out the value of pi or not. Okay, so let's see. Okay, so what did I say? First, we need to generate two random numbers x and y within -1 to 1. Okay, so how can I find out, or how can I generate two random numbers in between -1 to 1? I know that how to generate random numbers in between 0 to 1, right? If I write rand by rand max, then this is going to generate a random number in between 0 to 1, right? Now how can I generate a random number between -1 to 1? Let's see. So r is, suppose r is in between 0 to 1, then 2 into r is in between 0 to 2, right? If I multiply r by 2, I will get a random number in between 0 to 2. And now if I deduct -1 from 2r, then I will get 0 minus 1, which is -1, and 2 minus 1, which is 1. Okay. So that means if I multiply r by 2 and then deduct 1, then I will be able to generate a random number in between -1 to 1. Clear? So that means I can write that, sorry, this is not int, this is float. So then I can write that float x equal to 2 into r minus 1. Okay. Similarly, I am going to generate another random number. Let me call it r1. R2. In between 0 to 1, and then we map it in between -1 to 1 by writing 2 into R2 minus 1. Clear? And as I am using the rand function, I need to include standard library.h. Okay. And to ensure that different random number generation will be found in different run, I need to use the srand function. Right? So let's include time.h. So I need to keep generating repeated random numbers, and then I need to check whether these random numbers are in between or this random number is inside that circle or not. Okay, so let me put it in a loop. That is going to generate these repeated random numbers. And then after generating these random numbers, it is going to check whether these coordinates are inside the circle or not. Okay. Condition for checking is if x square plus y square is less than or equal to 1. If yes, then I'm saying that heat plus plus. Alright. So here heat needs to be initialized to 0. So I needs to be declared. Alright. That's it. So basically repeatedly I am generating two random numbers in between -1 to 1, and then I am checking how many times I'm getting heat. Okay. So once I'm done with this, I'm going to calculate the probability of heat, which is nothing but number of times I'm getting a heat divided by the number of total experiment. Okay. Number of times I'm running the experiment, which is 100,000. And then I can simply calculate the value of y by multiplying probability of heat by 4. That's all we have learned from the experiment. Clear? Okay. So let me run it and see whether I'm really getting the value of y or not. So I expected this. So you can see that the value of pi is coming as 3.152, okay, which is very close to 3.14. So if I run it more number of times, I'll see that value of pi is coming 3.139, which is also very close to 3.14. Okay, so if I run this experiment repeatedly, even more number of times, if I run, then I'll approximately get the value of pi. Okay, so 3.14 now I got. Okay.